Good afternoon.
Good afternoon.
All right, well, let's see who's here today and who's not. It's like we got people trickling in and out to say only one person in Hopi, or that two?
Taylor went to the bathroom real quick.
Okay. And, all right. All right, and let's see. How about in Alchse? Who do we have out today?
Chandra, Denicia, Leilani, and Akima are missing. And Kaya and Ariana should be here in a little bit.
All right, Tanja, help me go through that again.
Tanja,
Denicia,
Akima,
I got.
and Leilani. And then Ariana and Kaya should be here in a little bit.
Okay. All right, and how about Moyan?
All present.
All present and accounted for. How about what about Ash?
I moved to right here.
Oh, that's why. Okay.
Yeah, sorry.
Did you not finish?
That's all right. I'm just seeing the hole in the desk, that's all. Okay, that's cool. All right, well, so today our plan is to go through any questions that you have on anything chapter 6 and 7. If the questions end before the period, then I'll start in on 8.2. But if we spend 5 minutes in 8.2 or 30 minutes in 8.2 or no minutes in 8.2, it's fine with me. I'm already going to probably remove the questions from 8.2 anyway, because we didn't finish it in the morning class. So we got a little bit into it, but not enough. And I was already going to take off questions from 8.3 anyway. So I'm going to just take off questions from 8.2 and 8.3. So those won't appear on the midterm. The midterm, remember, is during class time tomorrow and Thursday. And then I won't see you because we'll have spring break. So I won't see you until March 23rd. Okay. So, and remember, if you have any quizzes you want to retake or second attempt at a test, it needs to be in before the midterm is finished. So before Thursday at 1:50 or whatever, you need to have any of your retakes done, unless you've made special arrangements with me. Okay? So, any questions as far as what's going on?
So last semester we had are we gonna do the what do you call it? The curve. Are we doing a curve again?
Oh, on the midterm?
On the midterm?
Did I curve the midterm last semester?
Yeah. Yes.
Yeah. Yeah, we probably will. Although I will say this is that in the past, I really haven't had to curve the midterm and trig much. I think last semester, my trig class, I had a number of A's on the midterm. So hopefully, you'll knock it out of the park and not even have to worry about the midterm. I mean, not have to worry about a curve. But yeah, I will if we need one. All right. Anything else before we start our review? Okay. So now I won't answer any questions that are about anything from any quizzes or tests, because there's still people that are wanting to take a second attempt or whatever. I'm still allowing that. But if you find something in the book, anything that you've been working on, the reviews, the book tests, anything that you would like me to go through, I'm happy to do that. So does anyone want to start us off?
So I have one. It's number 7 on the 7.3 exercises in the
Okay,
book.
7.3, number 7.
Yeah.
Okay. Okay.
Mr. Strong, that's not my problem.
Okay. Yeah, I was just double checking it. Okay. I was just kind of curious to see how many problems I had worked out on that section. Okay. So it says verify the following trigonometric identities. Okay, so the way we did, so basically what we have to do is we've got to get one side to match the other. That's what it means to verify. And so the way that we did ones with 3x or whatever is we used the wrote 3x is 2x plus x. So if we think of this as tangent 2x plus x, then that would give us the tan of 3x. All right, now we're going to use the u plus v formula. And I'm looking at the sum and difference identities in the back because there's two ways. Well, tangent of u plus v. Let's write down the formula. So the tangent of u plus v is tangent u plus tangent v divided by 1 minus tangent u tangent v. And so right there I can kind of see a little bit of similarities, like maybe, anyway, But we'll see how it goes there. So I'm going to apply this formula here. And so I'm going to think of the 2x is the u and the x is the v. So then I'm going to get tangent u, so tangent 2x, plus tangent v, so tangent x, all divided by 1 minus tangent u, 2x, times tangent x. Okay. So, all right, so the next thing I think to do is to break down the tangent of 2u. So using the double angle identities, okay, so here's another formula that I'm going to use, is that the tangent of 2u is equal to 2 tan u divided by 1 minus tangent squared u. So now plugging that in for these tan 2x's, all right, so now I'm going to get tangent, well, let's see. So in place of tan 2x, I'm going to put all of that. So 2 tan x over 1 minus tan squared x plus tan x over, so 1 minus, okay, tan 2x, I'm going to put this part in again. So 2 tan x over 1 minus tan squared x times tan x. That is pretty nasty. Some ugly stuff there. All right. So trying to simplify that, the thing I would think to do, because we don't like complex fractions. There's no complex fractions into what we're supposed to end up with. And so to simplify that, I'm going to multiply by the little denominator 1 minus tan squared. So I'm going to multiply top and bottom by 1 minus tan squared. All right, so then in this first, so when I distribute this to here, it's going to cancel with the denominator. All right, so I'm going to just get 2 tan x plus, and then when I distribute it here, I'm going to get tan x minus tan cubed x. So then the same thing in the denominator here. Well, when I multiply it by 1, I'm going to just get 1 minus tan squared x. Then when I multiply by the second term, the denominator is going to cancel. So I'll just get minus 2 tan squared x. Okay, so now I have like terms in both the numerator and the denominator. So let's simplify that. So 2 tan x plus tan x would be 3 tan x minus tan cubed x. And then in the denominator, I have 1, and then minus tan squared x minus another 2 tan squared x would be minus 3 tan squared x. And let's see how close we are. Okay, so 3 tan minus tan cubed. So I've got the numerator. 1 minus 3 tan squared. I've got the denominator. So I'm done. Okay. So you're just trying to, now that certainly wasn't easy because I had to use the so I had to use the tan u plus v formula and the tan 2u formula, and then a lot of algebra. All right. Okay, any questions on that one?
Dr. Strong,
Yes.
Ariana is here.
All right. Thank you. All right, so is there another question?
Okay, in section 7.1,
Okay.
practice B, can we go over that again? Because like I was trying to follow along, but then I got lost and then I never got the answer.
Oh, on the
Or notes.
I didn't know.
Student Success Organizer?
Yes.
Okay. So 7.1 practice which one?
2B.
Okay. Okay. So this is tan x minus secant squared x over tangent x. So the reason why I drew a line here and put a 1 underneath is I was thinking about getting a common denominator so I could add those two fractions. So anytime that you have a fraction, you want to try to put it over one fraction. And so in order to get a common denominator of tangent x, I need to multiply this first term, tan x, by tangent over tangent. So then I'll have a denominator of tangent. So then tangent times tangent is tangent squared x, and then minus secant squared x over tangent. And now you can put that as one fraction, tangent squared minus secant squared x. So what's tangent squared minus secant squared? So if you look at the Pythagorean identities, so back flap of your book, second column, more than half the way down, there's the Pythagorean identities. So tangent squared minus secant squared, what would we get?
Is it 1?
Close.
Negative 1?
Negative 1. And the reason why it's negative 1 is that, see, this is how it appears in its original form. And then when you subtract secant squared and then subtract 1, tangent squared minus secant squared is going to be negative 1. So, sorry. Achoo! Oh,
Bless you.
thank you. All right. All right. So, yeah, the good thing about taking class through the talent class is you can never get any viruses from your professor, right? So, all right. So then we end up with -1 over tangent x, which is negative cotangent x. All right. Any questions on that one? Okay. Other questions?
One sec, we're looking.
Okay. Now it's supposed to be one that you've worked on, that you've been studying.
I have a couple. I lost my sheet,
Oh, okay.
but I do have one in the book that's similar.
Okay.
Let me see where I'm at. I'm on 7-2, practice 3C. Oh, I'm having trouble with these ones for some reason in the book and everything.
Okay.
Oh, yeah.
Okay. So practice 3C. So the main thing you have to do in these, to write these as one sine function, is you need to make sure you have the formulas written down right on this. Okay. So let's assume you've got that. So the first thing you do is identify the A and the B. So the A and the B are like your coefficients here. So think of this as like 1 and this is 1. So the A would be 1 and the B would be -1. Okay. All right. Now the next thing you got to do is do the square root of A squared plus B squared. So in this case, you have the square root of 1 squared plus -1 squared. Well, that's 1 plus 1. So you end up with square root of 2. All right. The next thing you can do is you got to figure out the angle. And so the formula is that the angle, that the cosine, see, we don't have a formula to directly calculate the angle, but the cosine of the angle is A over the radical. So we get 1 over radical 2, which is the same as radical 2 over 2. And then the sine of the angle is -1 over the radical. So -1 over radical 2, or negative radical 2 over 2. So now we can use that in our unit circle to find the angle. So we say, okay, so the cosine is positive, the sine is negative. So that means we're in quadrant 4. So if we look, it's right there at 315 degrees. Or you could say -45. So that's our phi, our angle. That's how much it's adjusted by this formula, by combining them. Okay? So now your final answer, you put the radical, the square root of A squared plus B squared, which was radical 2, times just the sine of the angle, which was 2x, and then minus 45 degrees or plus 315 degrees. How either way is the correct way to write it.
So when you do your A and your B, if
Uh-huh.
it said if it was a 2 instead, would you still put the 2 over the?
Yes.
Okay. So
Yes.
and that's always cosine with those ones, or
Well, the cosine is the A
right?
over the radical, and then the sine is the B over the radical.
Oh.
Okay.
Okay. So what you get for A and B are going to appear here and here.
Okay.
Okay.
That makes a little more sense.
Okay.
Thank you.
Okay, that makes sense.
Yeah, I remember I actually never learned this formula as a trig student. And it wasn't until I was actually teaching that I even knew that you could write all trig functions just as sines. I didn't even know that. But apparently that's like a big deal in like if
Like I was spacing out, Mr. Strong.
it's what?
Dr. Strong, I was gonna ask, where'd you get the A and the B from?
So the A and the B are the coefficients, right from the very beginning. So if this is a 2 and this was a 3, then A would be 2 and B would be -3. But since there's not a number in front, the coefficient's understood to be 1. And in this case, since there's a negative, it's understood to be -1. Okay?
Thank you.
You're welcome. All right, any other questions on this one? All right, how about the next question?
I had a question on the 7.4 exercises
Okay.
for number 68. It says to give the exact solutions when appropriate and to round your answer to the nearest tenth. And the question is tan x equals cotangent x, and I was unsure how to find the exact answer.
Okay. All right, let's do that. 7.4, number 68. Okay. So, one way to do this let's see, if we go back to the problem we just did. Okay? One way to do this is to look at the unit circle. Okay? Now, we don't have tangent or cotangent on here, but cotangent is cosine over sine. Tangent is sine over cosine. Okay? So, where would those be equal? Where would tangent and cotangent be equal? Well, if the sine and the cosine are equal, then it doesn't matter which one's on top, which one's on the bottom.
Is it 45?
So 45 degrees is one answer because, see, the sine, radical 2 over 2, cosine is radical 2 over 2. So when you divide those, you get 1. Well, if you put the cosine on top, you'd still get 1. So one of the answers is 45 degrees. What's another answer?
225?
225. Because it's for the same reasoning, only it's negative. So that's 2 of the answers. Are there any more? Where the cotangent and the tangent would be equal. Well, let's think about at 135. Okay? See, the sine over the cosine would be, it's the same thing, so you'd have a negative 1. The cotangent, cosine over sine, it's the same thing, so you'd still have negative 1. So at 135, the tangent and the cotangent are also equal. Okay, there's one more.
315?
At 315. Okay, so the first way I would go about doing that is from the unit circle. Okay? Because you can't really, it's hard to figure out how to do it algebraically. Okay? But I'm going to show you how to do it algebraically anyway. Okay? So if the second way to do it algebraically would be if you rewrote cotangent as 1 over the tangent. Okay? And then now this becomes a proportion. So the way you solve that is cross multiplication. So you get tangent squared equals 1. Take the square root of both sides. So tangent x equals plus or minus the square root of 1. So tan x is equal to plus or minus 1. And so we already found those on the unit circle. It's at 45, 135, 225, and 315. Okay. All right. One other way is that, now remember, if you're struggling with solving any kind of equation, you can always put it in your calculator and find the intersection. So let's do that. Okay. So on the left, we're going to put tan x. Now, whenever you're graphing trig functions, what mode do you need to be in?
Radian.
You need to be in radian mode. So you want to make sure, double check that you're in radian mode here. Okay? All right, so for y equals, I'm going to do tan x, and then on the right side of the equation was cotangent of x. So the way I put that in, how do I put that into the calculator? How do I put cotangent of x?
One divided by tangent.
Good. Okay. So then when I graph those, so there's my tangent graph. And there's my cotangent graph. And see, they're going to have a lot of intersections. So let's say I want the answer just between 0 and 360, just between 0 and pi. So then I would change the window to just go between 0 and 2 pi. So I only see the ones that I want to see. So again, there's the tangent, and here comes the cotangent. Okay, and so there's 1, 2, 3, 4. Guess what? 1, 2, 3, 4 answers that I got. So I'm going to find each of them, but they're going to be in radians. So if let's just go ahead and find one of them. So second calc intersect. So first curve, second curve. Then when it says guess, I just want to go by whichever one I want to find. So I think I want to find the first one. Okay, so that's the one I wanted to find. So there's the answer. So 0.785. Now remember that that is in radians. So how do I convert? How do I convert from radians to degrees? So if I have 0.785 radians, how do I know that that's 45 degrees? How do I convert that?
You multiply it by 180 over pi.
Right. So if I take that, so 0.785, and if I multiply that by 180 over pi, then I should get pretty close to 45. And I do. Okay, so that sort of checks it for you. Let you know. And so you do that for each one. Now, but how much easier was it to just pull the answers off the unit circle? That's why it really helps to know the unit circle is it can make things easier. But if ever you have an equation that's baffling you and you don't know how to solve it, then you can put it in the calculator. Put the left side in for y1, the right side in for y2, and then find the intersections. Okay? All right, other questions?
Dr. Strong,
Yes.
on the same chapter 7, 7.4, can you do 73?
Okay. All right, so we have solve the following equations in the interval from 0 to 360. Give the exact solutions when appropriate, otherwise round to the nearest tenth. Okay, so here we're going to have 2 sine x cotangent x plus radical 3 cotangent x minus 2 radical 3 sine x minus 3 equals 0. Okay. All right, so initially I'm not loving this because I have 2 different trig functions. So you can't factor or anything when you have 2 different trig functions. So what I'm going to do is break down cotangent into cosine over sine and see if I can do something with it. Okay? So this would be 2 sine x times cosine x over sine x. So theoretically that could cancel. Plus radical 3 times cosine x over sine x minus 2 radical 3 sine x minus 3 equals 0. Okay, so I mean, I can see how to cancel that. But then I think I would have to get a common denominator to combine all of that. So instead of canceling the sine x, what I'm going to do is multiply everything through by sine x to clear it out. Okay? All right, so I'm going to take this whole thing, whoops, not that thing, this whole thing, and multiply it through by sine x to clear the fractions. Okay? Okay, so here the sine x's are going to cancel, and so I'm going to get 2 sine x cosine x plus, here the sine x's cancel, and I get radical 3 cosine x minus 2 radical 3 sine squared x minus 3 sine x equals 0. Ah, okay, so finally I see it. So now, yeah, it's interesting how it's algebra here that's going to help us. See, I'm looking at, and see, I don't have really like terms that I can combine, and so in my mind I was thinking, well, let's factor by grouping, because that's what we would do in algebra if we had 4 terms and no GCF. We would look at the first 2 and say, okay, what can I factor out of here? And it would be cosine. Whoops, how did that just do that? So cosine x, and I'd be left with 2 sine x plus radical 3. All right, and then here, if I factor out a negative sine x, then I'm left with 2 let's see, wait a second. 2 radical 3. See, I need it to match inside here. That's kind of mean. All right, so, but let's do it. All right,
You
let's
can
back
take
up.
out you can take out the square root of 3, I think.
Yes, that's excellent that you saw that. Because see, we're not used to factoring out a radical 3, but great job. Great recognition there. So negative radical 3 sine x. And now the stuff in parentheses will match. I'll have 2 and the other sine of x minus, or let's see, we factor out the minus. So plus radical 3. Good. Okay, so now I will factor out that common binomial 2 sine x plus radical 3. And then in the other binomial, I write down what I have left from each term. Cosine x minus radical 3 sine x. Okay? So that's probably like, I mean, what we just did was like a level 5 factoring. Okay, so now we set each factor equal to 0. So 2 sine x plus radical 3 equals 0. And cosine x minus radical 3 sine x equals 0. Okay, so this one on the left looks a little bit easier. Subtract radical 3, so I get 2 sine x equals negative radical 3. Divide each side by 2. So what angles have a sine of negative radical 3 over 2? So look at the unit circle.
Are you gonna say
240
it? Yeah.
240
and 300.
and 300. Okay. All right. So now this right here we might need to put that in the calculator. So where is cosine of x? Oh, here we go. We could do this. Actually, we could do this with the unit circle. So where is cosine of x equal to radical 3 times sine of x? So in other words, think about this. I mean, where is like sine of x 1/2 and cosine of x would be radical 3 over 2. So where is that on the unit circle? Where is the sine 1/2 and the cosine radical 3 over 2?
30 degrees?
Okay. So 30 degrees.
How about, and then 330 degrees?
And then so then where is the sign -1/2? And the cosine would also be negative. So where is the sine -1/2 and the cosine negative radical 3/2? So it'd have to be in quadrant 3.
Yeah, 210.
210. So those would be our answers there. Now, if you didn't see that, then you could, that one you'd probably have to put in your calculator. But it's actually the radical 3 that made me see, I can figure that out with the unit circle. Okay? Now, the thing is that while I want you to be able to solve trig equations like that, I cannot give you one that bad because you only have so much time, and there's going to be like 20 questions on there, and 9 of them are what I call quick hitters, where I might ask you what's the sine of 1/2, or what angle has a sine of 1/2, or what's the tangent of 45 degrees. Those are what I call quick hitters, where if you know your unit circle or you know how to use your calculator, almost half the test you should be able to do in seconds. Okay? I mean, it should only take, if I say what angle has a sine of 1/2, when you've got the unit circle in front of you, that should not take you very long. And so there's 9 of the questions that are supposed to be pretty quick. And then the other ones are not going to be like this. Okay? That would be kind of ridiculous. All right? So anything else? Okay. Well, we'll just pick up 8-2 on March 23rd when we come back from spring break. And in the meantime, good luck on your midterm tomorrow and Thursday. Don't forget, if you need to make up anything, it needs to be in before the midterms are over. Okay? Anything from chapter 6 or 7.
Hey, Mr. Strong, this is about the midterm. You said there's going to be like 20 questions. Is it going to be like 10 Wednesday, 10 Thursday?
No, it'll be 20
20?
each day.
Okay.
20 each day.
Sorry.
Okay. All right. And if you have any questions or concerns, don't hesitate to email me. So I won't see you till after spring break, but I'll be, you can have access if you need to get in touch with me. Okay. All right. So good luck, everyone.
Have an incredible spring break.
Bye.
Bye.
Yeah, bye. Thank you.